Now, among the other techniques for generating random numbers is the mean-square method. The first random number is generated in this process from the seed by squaring the seed and discarding all the digits except the middle four. This number is subsequently used as the new seed to generate the next random number in the same manner, and so on. The formula is x subscript n plus 1 is equal to s subscript n square. This should be n plus 1, n plus 1. So the mean square method is rarely used these days as it has the tendency to degenerate rapidly. Also, if the number 0 is ever generated, then the method is then all the subsequent number generated will be 0. Furthermore, the method is slow when simulated in computer since many multiplication and division are required to access the middle four digits. So all these drawbacks here, they impede the utility of this particular techniques. However, let's take a look at how it works in real life. If, for instance, we have the seed value to be 5497, we'll take the square of this seed value, which is x naught square, to give us 5497 square. This will give us 302.17009. Then we pick the middle four values. If we eliminate 1, 2, we eliminate 1, 2, we'll have 2170. So x1 will be 2170, and this one represents R1. Then x1 square will be equal to this 2170 square, which is equal to 0.47089000. In the same vein, we select the four mean values here to give us x2 and R2, which is 7089. So when we obtain this, we continue to take the square of this value. Then this gives us 50253921. This forms the S3 and R3. This forms the S3 and R3 is the extraction of the mid four digits here, which are 2539. Then when we continue like this, it will get to a point where it becomes 000. So all of these number here will form the various random numbers generated using the mean square method. Now, apart from the mean square method, there is another technique called the mean product method. This method is similar to the mean square method, except that a successive random number is obtained by multiplying the current number by a constant c and taking the middle digits. Formula is x subscript n plus 1 equal to c multiplied by xn. So instead of having the square of this as we had previously for the mean square method, we multiply by this constant c here. So the mean product method has a longer period and it is more uniformly distributed than the mean square method. Invariably, this one is mostly preferred in the real life. Now, let's look at an example for the mean product method. Generate a sequence of 4-digit random numbers with seed value 2938 and x naught equals to 7229. In this case, u1 is equal to x naught prime multiplied by x naught. So this one will give us 2938 multiplied by 7229, which is equal to 212388802. However, we pick the four middle digits to give us 2388. So this one forms the R12. And for us to get the X2, we multiply this R1 by the X naught. Multiply this R1 by the X naught. So we have 7229 multiplied by 2388 to give us this. Now select the middle four digits here to give us 2628. This forms the arrow 2. Now we will multiply this arrow 2 not with the x naught this time, but the newly generated numbers, which is the 2388. So we have 2388 multiplying 2628 to give us 06275,664. Now when we extract the four middle numbers here, we'll have 2756 to be equal to R2. Then we'll continue this same process just like we did in the previous step, the previous method, till we arrive at a point where all the values become 0, 0, 0. So this is how you generate using the mean product method. Now there are two other techniques that we're not going to discuss here, but I'll give you an assignment that you're going to write a brief description or discussion on these two methods. They're the quadratic congruential method and the Fibonacci method of random number. I want to give a brief description of this and with at least an example to describe each of the methods or techniques. So thank you for watching.